Welcome to today's Makino Experience Center event. My name is John Einberger. I'm the product line manager for horizontal machining centers here at Makino. One piece of housekeeping to get out of the way up front, we'd like to get questions from you. We'd like to address the questions that come up during the course of today's presentation. The way that you can do that, through the chat function that's up on your screen. I have it circled in red as an example. Use that chat function to get the questions in. We have people here monitoring what's coming in, and we'll address those at the end of the presentation. But again, easy to use. We look forward to hearing from you. Today's topic, 5 outstanding features of the Makino a71nx and a81nx horizontal machining centers. A little bit of background on the Makino NX series machining center, starting with our 400mm Cat 4851NX, all the way up to its much bigger brother, the a120nx, 1000mm pallet Cat 50, very common architecture amongst this entire line of machines. We'll focus today on the two smaller Cat 50 variants, the a71nx and the a81nx in detail, but just understand what I talk about today really applies over that entire range of machines. So with the a71nx, we feature a 500mm size pallet. The a81nx, a 630mm pallet, same spindle between the two. Horizontal machining centers, as you would expect, standard with a pallet changer. Cat 50 class spindles, so available Cat 50, as well as HSK A100, the equivalent HSK size. And they share the same NX family architecture, the same kinematic design, the same spindles, the same tool changer, the same Pro 6 control. All the elements that I talk about today in those various areas really translate between the two model machines. So moving forward to the first outstanding design feature, the most basic element of the machines themselves, the casting and the axis structure. So if we take that base bed casting, tip it up on its side, I'm highlighting the 3 points that have the only influence of the Makino design relative to the leveling of the machine at your site. All of the elements of the machine relative to other elements of the same machine are held in place from an alignment standpoint based on that bed casting. So really no effect of the inter-item alignment with the Makino design. So this is what we call true 3-point support. Again, only those 3 points that touch the ground have any influence as to the leveling of the machine. This reduces the cost and complexity of the required foundation that the machines sit on. In most basic terms, really what we're wanting, all 3 of those points that make up the triangle on the same contiguous piece of concrete. This expedites the installation of the machine. Our service engineer, when they come in to install the machine at your plant, they spend very little time having to align the machine because really they're only setting level. The alignment of element to element on the machine already set in the assembly process in its factory in Japan. That bed casting design, as I mentioned, established, maintains that machine geometry. So over time, no maintenance is required from the standpoint of realigning that machine tool. You need to be a little bit careful about what's in the competitive marketplace, particularly when you get to this size machine. This is a competitor's machine, their terminology, data from their installation manual, a machine that's billed as a 3-point level, and those are the 3 points right there. In addition, their terminology, the addition of 2 sag supports, the addition of a pallet changer twist support, and a Z-axis twist support. So again, machine overtly advertises 3-point level. In reality, 7 total supports on that machine that have a direct effect on the alignment of the machine tool. So everything out there is not necessarily equal. Really a question to really pursue when you're examining what machine tool you want to move forward with. So taking that bed casting, tipping it back down, bringing the column casting into place. The design feature that Makino continues to use since it was introduced in the mid-1990s on our A55E, continue to use it very successfully today, the stepped bed column design. By that I mean when we look at the column, the linear motion guide closest to the spindle is at a much different plane than the linear motion guide that's furthest away from the spindle by design on purpose. What this does from the standpoint of usage of the machine, it creates a very efficient force path from the cut through the spindle, through the column, through the bed, and ultimately into that foundation. It minimizes the length of that force path. Direct effect of that, minimization of the structural deflection of that overall assembly. Upside to the customer, first and foremost, the ability to utilize the entire Y-stroke of the machine for high metal removal rate cutting, not just low down close to the pallet top, but also as you move up, the ability is to sustain high metal removal rate cuts. You can do that due to, again, the overall increased rigidity of that overall machine assembly. Another upside, increased X-axis movement performance. So since we've taken mass out of the moving column for an X-axis move into and out of the page, we've translated that mass and made it static as part of the bed casting. We're accelerating and decelerating a smaller mass. Becomes much easier to do that, and also to very accurately, very repeatably position that axis of the machine. Overall increase in performance. In that result, geometry of the machine is what we see behind me. The kinematic layout, again, this has been very common in the Makino lineup since that A55E introduction, continues to be very common today. So the key point, the key takeaway, the bed and the column designs result in very outstanding rigidity that maximizes productivity, and the other sustainable upside that the customers experience, minimization of perishable tooling cost. Next point, way cover system on the machine. We know that the way covers often from a historical standpoint can be a very large consumer of customer maintenance time, maintenance expense. We went to great lengths with our NX series machines to minimize that by focusing on simplicity. So if we look at the view here, what I'm going to highlight in blue, the Z-axis covers on the machine. Single piece covers. So as that Z-axis moves, you don't have a cover that collapses amongst itself and then extends either on the front side of the Z or on the B, but single piece covers, no moving parts. We had to get very creative from the standpoint of the overall design of the machine and create cutout areas in the bed casting for those covers to retract under. That allows the use of the single piece covers, hallmark design of the Makino product, dating back to the predecessor to where we're at today, the a81nx, started that revolution in 2001. Upside to the customer has been very, very strong, very compelling to continue to pull this design forward. We apply that same design element to the X-axis cover on the 71nx and the 81nx, in that it's single piece. As that spindle moves left to right, no collapsing elements, single piece cover slides behind the area that you see in the machining chamber. Very, very simple design. The only cover on the machine that has articulated elements is the Y-axis, and those elements are pantographed on the back side of the cover, really to tightly control the motion of each segment relative to each other. But overall, very, very simple design. Key point, key takeaway, by designing the covers as an integral part of the overall machine tool, that allowed us to use very simple designs, very reliable designs, something that takes operating costs that may normally be associated with an HMC directly off the table. Third point, active thermal management. One of the things in the competitive marketplace that we see very overtly advertised on the non-Makino product is what I'm going to term passive thermal management. The use of standard scales to monitor displacement offsets of a machine as it heats up over time and try to compensate for them electronically, or something that may be billed as a thermally symmetrical design, again with offsetting in mind to counteract what happens from a heating standpoint on the machine tool during use. The Makino tactic is very, very different. It uses what we call active thermal management. The basic premise, instead of allowing thermal events to happen and then compensating for them after the fact, we prevent the thermal action from happening, period, so we don't have to compensate for it later. We use the bed casting temperature as the base data point. That's fed in through the control system to an active temperature controller that outputs cooling oil to various elements on the machine held within a 2 degrees centigrade window plus minus to that bed casting temperature. The bed casting, bear in mind, is the biggest thermal mass on the machine. It's going to react at the slowest rate relative to any ambient temperature changes. It also is responsible for maintaining the majority of the alignment of the machine tool proper. So very good data point to use from the standpoint of conditioning every element that's serviced by that oil temp controller with the right temperature oil. Specifically on the machines, we're going to send that cooling oil to the spindle, to the ball screws, and on the a71nx, since it has a direct drive B-axis design, to that B-axis unit. So we'll surround the spindle, pull the heat of that unit out of the equation, in through the non-driven side, out through the driven side of the ball screws, and around that integral direct drive B-axis table on the a71nx. As a side note, the a81nx has a motor that's outside of the table unit itself. We don't need to core cool that unit, but we certainly do on a direct drive integral design like the 71nx incorporates. So that cooling oil goes through that circuit. Note that this is not lubricating oil. This is temperature control oil only. The other thing to note, coming in through the non-driven side of the ball screw, out through the driven side, that allows us to isolate the heat from those axis drive motors, pull that mechanically out of the equation, and not let it affect the overall thermal stability of the machine tool. A little bit of thermal data to look at, showing the effectivity of the overall Makino system. What we're going to look at here specifically are the X-axis drive unit elements, the ball screw and the drive motor. We started out with a machine that was dead cold, not even powered up. What we're going to do is turn the machine on and run a production program continuously for a number of hours, a period of time, and look at what that thermal effect is. So dead cold to 2 hours, very little heat gain relative to that 2 hour period of time of running that same production program. 4 hours in, very stable. 6 hours in, again, continuous operation, a very high degree of thermal stability, exactly what we would expect when we've got a core-cooled ball screw system pulling the heat of that drive motor out of the equation. Through a customer relationship, we are allowed to run exactly the same test, exactly the same program on a competitive machine that uses scales as standard, just to see what does that mean from the standpoint of not actively pulling heat out of the equation. What's the overall effect? Same test, same element on the machine, dead cold, 2 hours in. If we look at the heat gain 2 hours in on the non-cooled machine relative to the Makino, very significant increase in heat gain, much bigger increase in heat gain 4 hours in, and even more so 6 hours in. So again, the overall tactic on the non-Makino side, let the heat saturation happen, compensate for it. Makino design, very, very different. Keep the heat event from ever taking place. So what does it mean from the standpoint of a takeaway to a customer using the Makino overall system? Very high level of accuracy, plus minus 2.5 microns accuracy, plus minus 1.5 microns of repeatability, full stroke, bidirectional on all axes without the use of scales. We do offer scales as an option on these machines. To be very candid, it's a relatively unpopular option only from the standpoint of the incredible capability of the machine without using that level of electronics. The two industries that really are interested in scales, the customers that make optics platforms, the customers that make semiconductor manufacturing equipment, to those customers, 0.5 micron either direction makes a difference. The majority of customers at 2.5 micron, that 1.5 micron, well within the capability to give them overall process stability. So key takeaway point, by actively removing heat and not trying to react to it after the fact, customers enjoy sustained dynamic accuracy in the platform, sustained capability, but also an uptick in reliability and not allowing heat saturation in elements such as ball screws that have a pretty significant amount of impact to the overall capability of that platform. Next item, tool changer system. We know that this is a very highly used, very highly stressed part of the overall machine tool. We've done a couple of things that really addresses this. So whether the machine has the standard ring style magazine or one of our larger matrix style magazines, the tool changer elements really are the same, and we're going to focus on that area for this part of the discussion. So let's take a look first and foremost at the physical tool change. The S-arm unit that performs the tool change and its prime driver, all done through a cam box. One single drive motor comes into the cam box. The cam box then is responsible for all of the motions inside of this tool change S-arm. Everything from the rotation, the retention of the tools, the pull out, the 180-degree swap, the reinsertion, and the return to zero, all done through that cam box. Large bearings used, very high level of support. We know that we have fast tool changes as part of the overall system, but we need them to be very stable, very repeatable, and very reliable. But let's focus for a minute on something that might seem to be a very small detail, the tool retention device. So again, as that S-arm clip comes in 90 degrees, it clips over to the tool in the spindle, it clips over the tool that's in the ready position. That retention device is responsible for holding that tool in check, not allowing it to dip, not allowing it to drift, most importantly, not allowing it to come out of the S-arm during the rest of that tool change process. On the Makino design, spring-loaded for the initial engagement, but then collet locked around the perimeter of that detail to ensure that that device very securely holds those tools into place. A little bit different than what we see in the competing brand machines. One other element from the standpoint of reliability, that's an item that would be standard in the auto lube system that comes with the machine, the grease system that services the guides, the ball screws, other elements of the tool magazine, also is used to support lubrication of small detail devices like the tool retention area. Just an example of the attention to detail that we're paying really to ensure sustained reliability over a long period of time. Stepping away from the tool change proper to supporting elements, another example of attention to detail, the shutter mechanism that opens the door between the machining area and the tool magazine. We know based on customer data that's come back to us that it's not uncommon in production for a machine to see 2 million tool changes a year. Take that relative to that shutter door, that's 4 million cycles of opening or closing. Very highly stressed area of the machine that often we see in the competitive marketplace does not receive a lot of attention. Typically, this is going to be open in the competitive marketplace with an air cylinder, bouncing off the cushion on the open side, bouncing off the cushion on the closing side. Makino, again, attention to detail, we use a combination of servo drive motor and ball screw. Oftentimes when customers first see this, the reaction is it seems like overkill for such a simple mechanism, but when you think about the cyclical nature and how highly stressed that is, from a usage standpoint, from a reliability standpoint, it starts really making a lot of sense. Again, attention to detail. Key takeaway point, we know that the tool changer is a very highly utilized, very highly stressed part of the machine. We not only need to have a system that's fast, but also one that's very reliable. Last point, spindle offerings. We know that the a71nx, the a81nx are used by our customers in a whole variety of different situations, from automotive production to semiconductor, machinery, manufacturing, die and mold, industrial components, aerospace components. We have a variety of spindles that meet those needs. So let's focus first and foremost on automotive and industrial equipment. Very common usage on both of these machines, the standard 10,000 RPM high power spindle. 60 horsepower, 459 foot-pounds of torque. If we look at that torque chart, very high instantaneous torque. What that translates into directly on that 10,000 RPM spindle, very high rate of acceleration and deceleration. If we take that and translate to what that means in a production environment, very often we're going to see a significant number of holes that are drilled and tapped. Every time you rigid tap a hole, that's 4 acceleration, deceleration events for that spindle. Accelerate going in, decelerate at the bottom, accelerate coming out, decelerate as you exit the hole for impacts of where that very high torque value really comes into play by minimizing that overall cycle time. Standard interface on the 10K spindle, Cat 50, with an option for HSK A100. From a tool life standpoint, one of the things that we've seen a direct uptick in tool life based on customer feedback, the use of very large inner diameter bearings on the spindle design. What that translates to directly, the ID of the bearing will be the same as the outer diameter, the OD of the spindle shaft, direct relationship to the stiffness of that spindle shaft. Think about that tool in the cut, very highly loaded from a radial perspective. If we minimize the bending of that spindle shaft, take that out of the equation, uptick, a great increase in tool life, great increase in rigidity of that part of the mechanical system on the machine. One of the other things that we track on the machines very tightly, shipment of spare parts. I'm going to focus for a minute on shipment of replacement spindles that service the a71nx, the a81nx that we're talking about, but also its predecessor machines, the 71, the 81, the 82, and our current big 800 millimeter machine, the a92. All of these machines can use that same part number, 10,000 RPM spindle. So shipments of spare spindles to that overall installed base, a very good indicator of spindle longevity and reliability. If I look at the combination of those machines, again, they all use that same part number spindle installed in North America, South America, our area of responsibility at Makino Mason. From 2016 through 2021, you can see the installed base of the machines, up to almost 1,500 machines installed by the end of 2021 that use that same part number. If we overlay in there the number of spare spindles shipped to cover that population of machines, spindle shipments in red, extremely small percentage of the overall install base in spindle shipments on a year-over-year basis. Now bear in mind, a spindle shipment can be for any reason: to replace a spindle that's been crashed, to replace a spindle that's been worn out, since these machines can be in production as early as 2002 and still fit within that demographic, or something that happened on our side on the manufacturing front. Point is, very small percentage of the overall install base do we see as spindle shipments on a year-over-year basis. Very good indicator of the reliability of that system. Moving forward with the a81nx, we see some customers doing very heavy metal removal in more difficult alloys. Think about compacted graphite iron, think about some of the nickel-based alloys. We offer on the a81nx an 8,000 RPM super high torque spindle. 74 horsepower peak, but 886 foot-pounds of torque. A lot of times in these processing situations, surface footage is not your friend, but chip load is. That high torque for sustained period of RPMs certainly aids in the heavy metal removal capability that the a81nx platform can otherwise manage. As was the case with the 10K spindle, Cat 50 and HSK A100 are the two spindle interfaces available. For our customers that do high metal removal but in other areas, think the machinery that makes semiconductor machines, also aerostructural, so aluminum machining, or also small tool die mold cavity machining. We offer a 15,000 RPM spindle as the first available option. This is a new spindle in the Makino lineup, very efficient. It's an oil air design, so very little parasitic loss of spindle output as that speed is elevated all the way up to 15,000 RPM. Available as an option on the a81nx. 74 horsepower, 390 foot-pounds of torque. Because of the elevated speed of this spindle, HSK A100 is the only offered spindle interface to protect from tool drawback and spindle bell mouthing that would occur with a steep taper design. One other alternative, our option number 2, our 20,000 RPM spindle, also available as an option on the a81nx, 94 horsepower, so elevated horsepower again over what we even saw in the 15,000 RPM, really comes into play for that super high metal removal rate capability that the aerostructural type customers really enjoy. One of the key design elements, sustained high horsepower output, all the way from 10,000 RPM up to the peak 20,000 RPM value. And similar to the 15,000 RPM spindle, standard HSK a100 interface. So in closing out the spindles, the key point, the systems are designed to provide high performance outputs, but also with a very keen eye towards reliability. So in summary, the combination of the casting and the axis structure design, the way cover system, the use of active thermal management, the tool changer, and the spindle offerings, we hope that they add up to profit for you. So thank you for your time today. What we'd like to do now is turn it over to the questions that you've inputted during the course of today's presentation, and we'll address those on a one-by-one basis. Thank you.
Okay, question that has come in, talking about the spindles, kind of expanding the discussion a little bit. Are the spindles that you talked about today that are used on the 71 and 81nx, are those available on the other machines that are in that NX family that are larger? And the answer is yes. In particular, the 10,000 RPM spindle that I talked about is standard on the larger 800 millimeter pallet A92. And the 8,000 RPM high torque spindle is standard on the even larger A120nx, the 1,000 millimeter pallet machine, and an option on the A92. Last point, the optional 20,000 RPM spindle that I talked about continues to be an option on the A92 and the A120nx. One other question has come in. We have a program that looks like the a71nx would be a good fit. Can we set up a direct discussion to talk about our program? The answer is yes. Best way to do that, talk with your Makino representative. If that's somebody that maybe you haven't dealt with in the past, you can always feel free to reach out directly to me, again, at john.einberger@makino.com. More than happy to take that call, take that email, and start the discussion, but we'll get our sales representative tied in, and we'll go from there. A couple other questions have come in. What solutions does Makino offer to keep fines out of the coolant? In this series of machines, what you're going to find is a combination of filtration units on the machine. There's going to be a continuous backwash drum style filter that all of the coolant that comes out of the machine, the chips in the coolant that initially exit from the machine, go through that drum style filter. That's going to take you down to about a 50 micron nominal filtration level. Beyond that, then that coolant is going to go to another area of the tank. That clean coolant is going to go through a cyclonic filtration unit and go to what we call the super clean side of the tank, with the super clean after the cyclonic filter down to the 20 micron nominal level. And that super clean tank then is going to service the through spindle coolant circuit on the machine. So the combination of the permanent media filter down to 50 micron level, the standard cyclonic filtration down to 20 micron, really provides a good solution for the from the standpoint of getting the fines out of the coolant. One thing I do want to notice, Makino has very extensive experience using cyclonic filtration. It's something that we've been doing, depending on the model of machine, for almost 10 years now. And one of the things that you need to be mindful of when you look at the cyclonic filtration, I guess the first thing, number one, you have to be mindful of the material. What we have found is that in some of the ultra lightweight materials, and magnesium certainly comes to mind, I'll be candid with you, the cyclonic filtration really is not a super effective solution because the fines tend to be lighter than what the coolant itself is. So in that case, we have offered certain customers that machine magnesium on a regular basis a different secondary filtration system from a company named Boll, B-O-L-L. We've integrated that into the machine, and that's been very effective at those ultra lightweight fines, getting them out of the coolant. The other thing to be mindful of, take a real hard look at the design of the cyclonic filtration system. The thing that we found is that it's incredibly important to the effectivity of that system to be serviced by a dedicated pump. The cyclonic filtration units are very sensitive to having a very tightly controlled flow rate and a very tightly controlled pressure. So if the pump that services the cyclonic unit also services many other coolant areas in the machine, where maybe it's also servicing, say, the shower coolant or something like that, which turns on, turns off during the cutting process, that induces a lot of variability to the pressure and the flow of the coolant through the cyclonic and makes the cyclonic very ineffective. On the Makino design, we have a dedicated pump that services only the cyclonic for exactly that reason, to maximize the efficiency. The other thing that we learned from practical feedback is it's very important what you do with the fines that are filtered out through the cyclonic unit and how you dispose of them. What we initially tried was to use the flights of the conveyor to take those fines up out into the chip barrel. The issue that we've always found time and again, if you do that, which seems to be a reasonable idea, is that those fines will make their way back into the coolant system. So you're kind of in this continuous cycle of taking fines out and dumping them back in, taking them out, dumping them back in. We've gone to what we call a sludge box design to get the effluent out of the filtration unit. That totally separates it from the coolant system and doesn't allow those fines to migrate back in. Long answer, but a pretty complicated question, and something that, again, we have a lot of experience with, and I think we have a very robust solution in the market. The last question that I see right now has popped up: are the machines available for automated systems? Absolutely. For the customers that have low volume per part number, but a lot of different part numbers, we can tie the machines into our MMC2 pallet handling system. So the pallet handling system would have a variety of pallets and their dedicated fixtures inside the system. All the CNC programs and tool data managed by the cell control, and the ability to pull programs into and out of production on very short notice with using that cell control as the scheduling medium. Again, that's the Makino MMC. That's something that can be integrated into the machine at any point in time down the road. The machine can be initially set up as a standalone and then run in the MMC configuration down the road. We also offer a pallet pool solution in single layer, dual layer, or 3-layer. Again, another way to handle that low volume, high mix scenario. For the opposite scenario of high volume, low mix, Makino has an integration group that offers a variety of different robot-based automation solutions. So again, appreciate you joining us today. And again, my name is John Einberger. Feel free to reach out to me at john.einberger@makino.com. And we look forward to talking with you again shortly. Thank you.